Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today we're going to estimate the area of a real space using a map and a key. We're also going to estimate the amount of objects in a space using unit rates and proportions. And lastly, we're going to be able to write a proportion 4 ways. I randomly chose a place on the beach and drew a square meter with my foot around the objects in the sand. Here you see a diagram of an approximate 1 square meter at the beach and all of the random objects that fell within that square meter. Also, I have a loose sketch of the beach that I was on when I took this picture. This is my scale drawing of what I saw on Google Maps of Loop Beach. The question we want to answer is about how many rocks are on Loop Beach. Now I'm going to use this 1 square meter to estimate how many rocks are on the entire beach. Let's look at some ratios. There are 9 rocks to every 6 shells, 9 rocks to every 25 total objects, 6 shells out of 25 total objects. Before we can estimate how many shells and rocks are on the entire beach, we need to estimate the actual area of the beach. Using Google Maps, we can see that 10 meters is this distance apart. Area is measured in 2 dimensions, so I'm going to extend the key of 10 meters to 100 square meters. 10 meters times 10 meters is 100 square meters. Using this, I'm going to try to break up the map into 100-meter blocks. I can fit 6 whole blocks into this space, and the rest of the block are cut off in some way. So I'm going to mix and match to try to make a better estimate. So using this strategy, a visual representation and tiling the key around the image, I would estimate that Loop Beach is 1,100 square meters. Let's try to set up a proportion to solve this problem. We need to decide which ratio is important to us. Is it 9 rocks to 6 shells, 9 rocks to 25 total objects, 6 shells out of 25 total objects? It's actually none of those. What we want is something that relates the rocks to meters squared. So we know that in 1 meter squared, there were 9 rocks. This is a unit rate because the denominator is 1. So 9 rocks to 1 square meter. We don't know how many rocks are on the entire 1,100 square meters of the beach. So we will try to find that value. We can rewrite this proportion 4 different ways. For any proportion, you can invert both fractions. You cannot invert one and not the other. You have to do them both at the same time, and they can switch places on either side of the equal sign. An easy way to rewrite a proportion 4 ways is to rotate the values clockwise by using 4 different colors. You'll see that each of the 4 values will rotate into each of the 4 positions. Now that we've rewritten the proportion 4 different ways, we can select which one is easiest to solve for the missing variable. Here we just have to multiply both sides by 1,100 to get x by itself. Here we could use cross products. X times 1, 9 times 1,100. Again, here I'd probably use cross products. Again, in this situation, we could multiply both sides by 9 and get our variable by itself.
All 4 of these proportions are equivalent. They all will show that x equals 9,900. I will demonstrate how to solve the first proportion, and you can try the other 3 on your own. Here we would multiply both sides by 1,100. The next line will show that 1,100 times 9 over 1 equals x. Simplify, and we get 9,900 equals x. Here we will use a ratio including shells and meters squared to show how we can estimate how many shells are on Loop Beach. We will use cross products to solve this. Using cross products, we multiply the numerator of one ratio to the denominator of the other and set those two products equal to each other. So here you see we have 6 over 1 equals x over 1100. Multiply 6 by 1100 and set that equal to 1 times x. Simplify and we get x equals 6,600 shells. Can you write this proportion 3 other ways and solve for x? Thank you for watching. Don't forget to subscribe, give this video a like, and in the comments below, let me know what middle school math concepts are muddy for you, and I'll clear them up.